right, you guys, this is the second part to the question that we just did. So we were looking at a table, and now we're going to create an equation to fit that table of an inverse variation. So let's pull up the calculator. And what I've done in the calculator is, if I go back to my list where I entered in data, if you can look into L3, when I went into L3, I know that since it's an inverse variation, my x times my x times y are going to be my constant of variation, okay? So what I did in the calculator is I went through and I'm multiplying. If you go into the next list, you can like type in numbers. So if you can see where I am in list 3, I'm going to type in 698.5, which is my x, times, now watch me here, I had a bad habit of typing in the wrong number last time, somebody caught it, times 53.3, which is my y, okay, and that's how I'm getting that number in the column. I'm just multiplying what's in L1 times what's in L2, so x times y, and I'm going to do one more, times 47.5, okay, and it all looks to be about 32,200, and then I have a low number that's 07 and a high number that's 40. So my k that I want to use for my equation is going to be somewhere in between those two numbers. So I'm going to go with 235. If you wanted to be really precise, you could find the exact average there or pick a different number. Since we're dealing with real world situations, you're never going to have a perfect number. So I'm just going to estimate that my k is going to be 32,000, well 35 might be high, let's go with 30, 37,230. So k equals 37,000, I think I was saying 32 earlier, it's hard for me to talk and write at the same time. 37,230 is the estimate I'm going to go with. So when I write my equation, you don't really want to write your equation as x times y, you want to write it as y equals. So I know the formula we learned earlier was y equals, and it's going to be your number over x. So in this particular case, it's going to be my k, 37,230 over x. And this is going to be the equation I'd like to use. Equation of the relationship between, was it Hertz and tube length? I think it was. If not, just go back to the other question and look. Hertz and, no, I don't want to do that, and tube length. One more interesting thing while we're looking here, remember how I told you that in your graph, and I'm just going to sketch this out really quick, of an inverse variation, you're never going to hit the x or the y axis. One of the reasons is that if you look on the denominator of our equation, we have x, and x can never be 0. I mean, in this situation, because you're dividing by it and you can't divide by 0. So that's why you're never going to have an x or a y intersect there. So the equation of the relationship between Hertz and tube length. And then we have one more question for this unit here.